In this video, I'm going to show how much difference the fuel mix makes to the power you get out of a rocket. So I'm going to make two different mixtures in two bottles. I'm going to need oxygen, so I'm going to start with some of this stuff, this manganese dioxide powder, and I'm just going to put a little bit on the end of a spatula. You don't need much, you'll see there's already a little bit in my flask anyway from where I tested before the recording. Put that in the filter flask, attach a tube to the hose connection so you can collect the oxygen. And then in the top you want one of these things, a tap funnel. I've already filled mine with hydrogen peroxide, just give it a gentle push to seal the top of the flask. And when you open the tap, the hydrogen peroxide runs in and starts reacting with the manganese dioxide. You can see it just there. Leave the tap open for a second to catch the back pressure, then close it until you want more. You want to get the oxygen that comes off into your rocket, so run the pipe you connected earlier through a water bath into one of your bottles. To help you measure how much gas you've transferred, fill the bottle with water beforehand and bubble the gas in from the bottom. You want to end up with about equal parts oxygen and methane in one, and 2 parts oxygen to every 1 of methane in the other. Make sure you use a PET bottle, because those are the only ones strong enough to contain the explosion, and don't be tempted to go over about 600 mils. What we're actually doing is burning methane in oxygen. So take a look at the unbalanced equation, where you've got equal parts of both molecules at the start. If you've done basic chemistry, you'll know that burning fuel usually gives off water and carbon dioxide, so that's going on the other side. However, like I said, this is the unbalanced equation. To balance it, you need the same number of each type of atom on both sides. So if we balance the equation, we get 2 molecules of oxygen for every 1 of methane, and that results in 2 molecules of water and 1 of carbon dioxide. This is why I've got 2 mixes. The bottle on the left represents the first equation, where we had equal numbers of methane and oxygen, and the one on the right represents the proportions we get from the second equation, 2 oxygens to every 1 methane. And that is how you make a methane rocket.